Okay, so we know that fx actually means p x less than or equals to x, which essentially means integrating from negative infinity to x, and then your PDF dx, right? So if we are given this transformation y equals x squared, we're trying to find gy actually. So I'm just write gy here. Gy is the probability that capital Y is less than or equals to y, which essentially is negative infinity to x, to y, and then gy. Okay, right. So how do we work this out? Well, we know that y is equals to x squared. That's the given transformation. We can actually replace this y here with x squared. Okay, and then we are trying to make x the subject. So to do that, we're going to move the square over. So we're square rooting both sides. So remember, whenever you square root an inequality, you actually end up with x less than or equals to square root of y, and then x is greater than or equals to negative square root of y. So there's a negative here because let's say you have x squared equals to 4. Square rooting both sides gives you plus minus 2, right? So one of the possible solutions has a negative in there. So you're multiplying by negative. So whenever you multiply by a negative number, you have to flip the inequality, which is what's happening here. So we can combine these two inequalities, and that's going to give us x is less than or equals to square root of y, and greater than or equals to negative square root of y, like so. Okay, just get rid of that. Okay, so what next? Okay, let me just try to draw that here. Let's say this is our PDF, some random function. Maybe it goes like this. So let's say this is negative square root of y, and this is square root of y. I know it's going to be on the left side of the vertical axis because square root of y has to be a positive number, right? Otherwise, this is not going to be well defined. We're not going to deal with complex numbers for this one. So therefore, this kind of looks like that. Obviously, the scale here, they should be equal, but I'm not drawing it to scale. But this is the area that we're interested in. So this area is actually the same as taking this is square root of y. So the area from infinity to square root of y minus, this is, let's say, negative square root of y. So minus this area here from negative infinity to negative square root of y. So if we take this area minus this area, that's going to give us this area, which is essentially this probability right here. So we can say this is actually x is less than or equals to square root of y minus p x less than or equals to negative square root of y. You can get rid of all of that. Okay, so okay, let's look at our PDF over here. Sorry, this is our CDF. Right? This guy is our CDF. So if you look at our CDF and you look at this definition here, you see that you're essentially just replacing this x with square root of y. Okay, and this guy is going to be 0 because we know that anything less than 0 is going to have a CDF of 0. So this thing is a 0. Now this guy, you need to use this guy over here. Okay, so that's going to give me square root of y squared over 16 minus 0. Okay, so this one is valid for the domain 0 to 4. So technically, I should write it like this. Hang on, just get rid of all of that. Let's get rid of this as well. And maybe move this here. Oops, hang on. Let's move this guy over here. Okay, so this is gy. And then we're going to do this. So this is valid for the domain 0. And then usually we'll put an x over here. But now we've replaced all the x's with square root of y. So we should put a square root of y over here. Right? So if you try to square both sides, because we are trying to make a y the subject here. So that's going to give me 16 over here. Square of 0 is still 0. Okay, so it's going to be 0 when y is less than 0. Do not include 0 because that's already defined for this function right here. And then if y is greater than 16, the CDF should be 1. And that's how you solve questions like these.